All right, you mathematical monsters. Sorry I couldn't be here today, but we are going to be checking out the process of completing the square. I'm going to show you some video notes, and I'm going to throw you into your homework, and hopefully you can get out of here without too much in the way of stuff to do at home. So, at the top of your notes, you can put completing the square, 5-4. And I wanted to show you just a preempt of what we're going to be looking at. So, if you have something nice like this, right, x plus 1 squared equals 16, this is not too bad to solve. It's kind of like saying y squared is 16. And you can just take the square root of both sides, right? If you take the square root of this side, the square and the square root cancel. And if you take the square root of this side, you get plus or minus 4, right? And so this whole thing just turns into y is plus or minus 4, 2 solutions. Neat? Neat. You can do the same thing with this, right? This is just x plus 1 squared. This is like y squared equals 16. And if you just take the entire square root of that side, take the square root of this, your square and your square root will kind of cancel out. You're left with the radicand, otherwise known as the junk under the radical. And on this side, you're left with plus or minus 4. And that's cool because you got two cases now. One is if the 4 is positive. If the 4 is positive, you clean it up by subtracting 1 from both sides. So this was x plus 1, and we subtracted it from both sides. And so negative 1 plus 4 is 3. Great, one solution. And then if the 4 is negative, you get another solution that looks like, again, subtracting 1 from both sides, and you get negative 5. And you can go back and check them and say, okay, let's see, negative 3, put it in here into this original equation. So it'd be 3 plus 1 squared. That's 4. So 4 squared, 16. Yeah, great, that works. Ping. And then negative 5, put it in there. So it's negative 5 plus 1. It's negative 4. Squared is, yeah, 16 again. Ping. So we checked it. Great. Well, this is a really nice way to get rid of the squares, right? The exponent here. Sometimes you have this sort of thing where you get this trinomial. And if you're really lucky, you can do this trick with it, where you change this into something that looks like this one. Like this, right? This is a perfect square trinomial, so it will factor into this. And if you're uncomfortable with that, I can show you it this way. You know it's going to be some sort of binomial x plus something times another x plus something. Ooh, I'm not sure about this thick calligraphy pen. Equals 28. And this should be 6 and 6, right? The x times x gives you x squared. 6 times 6 gives you 36. And you got 6 x's and 6 more x's, 12 x's. And then instead of just saying blah times itself, you say blah squared, right? So the quantity x plus 6 times the quantity x plus 6 is just x plus 6 squared. And then you can just do this trick with it, right? You can just say, all right, square root of that and square root of that. The square and the square root cancel. And you're left with the radicand, x plus 6. And the square root of 28 is the square root of 28. Neat. And then you can just subtract 6 from both sides. Minus 6. Minus 6. And then you end up with this, right? Negative 6 plus or minus root 28. And root 28, you can think as what? 4 and 7. 4 times 7 under the radical. And when the 4 will come out as a 2, so this should be what? 2 root 7. Neat. Okay, so we got two answers, negative 6 plus 2 root 7 and negative 6 minus 2 root 7. And of course we could check that. Cool? So that worked really well because this was a fancy kind of trinomial called a perfect square trinomial because it turns into something squared, right? It's this squared. It's not like x plus 2 and x minus 3, which is not a perfect square. You can't change this into blah squared and then take the square root, which is a nice trick, right? So what makes this perfect square trinomial perfect? Well, it's just this pattern it follows. Here are 3 perfect square trinomials, and here's how you factor them into their factored form, right? So, ooh, this one's wrong. There. So this is x squared plus 10x plus 25, and you'd break this into x plus 5 times x plus 5, and these two x's give you x squared, and the 5 give you 25, and you get 5 x's here, and 5 more x's here gives you 10x. Great. And so this is just 5 plus x plus 5 squared. If you look at this, in all of these do the same thing, right? These follow the same pattern, that if you take this b term and you cut it in half, you get what these are. Well, let's get rid of this. Let's take out the intermediate step. If you take the b term, you cut it in half, you get that term. And if you square that term, you get that. You get the c term. Right? Same thing here. -8, cut it in half. -4, square it. 16. 12, cut it in half. 6, square it. 36. It happens over and over again, right? And if you want to go backwards, you can just go, all right, 36, square root, 6, double it, 12, 16, square root, 4, double it, 8, right, etc. So there's this pattern that if you're looking at a squared plus b squared plus c plus, a squared plus bx plus c, you get that the c term really is the b term cut in half and then squared, right? And the b term is the square root of c doubled. Nice. Okay, so why we wanted to go through all that rigmarole is this. You don't have to pay attention to this part right now, but this is x squared plus 6x, right? And if we wanted to like add something here to make it a perfect square trinomial, well, what would it be? Well, we're going to do the same thing. We're going to take half of this and then square it, right? So I'm really trying to find out what this c term should be. It's half of b squared, and this is the fancy terminology for that. But we want this to be 9, right? And if this is, we got this 9 from this. We said half of 6 is 3, and 3 squared gives us what this guy should be, 9. And we did all that work, so now we can just say, this factors into x plus 3 and x plus 3, or x plus 3 squared. Right? So we've taken this, added a little something, and now we can make it look nicer as a perfect square trinomial. So here's a little practice. I want you to think about what you can add to each of these to make a perfect square trinomial. You can pause me, or you can just kind of follow along. We're going to take half of this, right, which would be 4, and then we would square it, which would be 16, right? And then we're going to do the same thing here. We're going to take half of this, which is 6, and then square it, which is 36. And we're going to take half of this, which is -5 halves, and then we're going to square it, which is going to be -5 halves squared. Yes, you can call it 25/4, but I'm not going to right now. Cool? So what all of that did was allow us to change these into perfect square trinomials, and I'm going to show you what that looks like. All right. So this guy, this piece, now that we have a perfect square trinomial, will change into x plus 4. Right? This piece that we found, squared. And this will change into x plus 6. Right? The 6 is this piece that we found, squared. And this will change into x minus 5 halves squared, right? The 5 halves is this piece that we found. Neat? All right. So we're going to try to use that to solve an equation, right? We're going to do that same sort of process. I'm going to show you, and then I'll give you one to try out on your own. Okay? So we have this x squared plus 16x equals negative 15, right? And what would be really nice is if we could change this, because it's really hard to factor this if you don't have your c term here. So we could totally move this negative 15 to this side and factor it. I want to try to do that without factoring. So I know that we got to complete the square on this side. Ignore the negative 15 for a second, right? So what's going to be our c term? Well, half of this squared, right? And if I add something to one side, I got to add it to the other, just so it balances, just like any other algebra. So we're going to cut 16 in half, 8, right? And then square it, and that's going to be our c term, 64, right? But then we also have to add 64 to this side. And that's great. We did all that work, so this side can be turned into x plus 8 squared, because this is now a perfect square trinomial, which is nice. And we cleaned up this side, and you got 49. Cool? So we did all that work, so we could take this square root of this side and square root of that side, and so this exponent will cancel out of here, and you just get the radicand. And on this side, you get square root of 49, which is plus or minus 7. And then you get the two cases where, 7 could be positive, and so you get x is negative 1, or 7 could be negative, and x is negative 15, right? And you could plug them back in and check both of them, that both of them are solutions. Bing. Cool? All right, moving on. So this is the same sort of idea, but instead of having this on this side, and just like this one, you could have factored this. On some of them you can't. This one we can factor, right? We could break this into x plus 9 and x plus 1, right? And so I'm guessing this is 1 and negative 1. So we know that we can solve this factoring. Let's try to do it completing the square. The thing is, this is not the right c. The c should be half of this squared. So this thing should be 25, right? So let's get rid of the 9. Let's move it over to this side. Right? So if we move it over to this side, we subtract, and this ends up being 9 over here. And so we're going to put our x squared over here and our plus 10x over here. And now we can take this b value, cut it in half, square it, and that's what we're going to add here, right? So I'm going to add 25 over here. Ooh, and also I'm going to add 25 over here, because we got to make things balanced. Right? So this really is x squared plus 10x plus 25 equals 16. And we did all that work so we can factor this side into a perfect square trinomial. It'll factor into x plus 5, all squared, equals 16. And we like that format because then we can just take the square root of this, the square root of that, the square root and the square cancel. You're just left with the radicand, x plus 5. Oh, that's a terrible 5. And then on this side, you end up with plus or minus 4. Yeah? Ooh, that's not your bell, that's my bell. So, if the 4 is positive, you'd subtract 5 and you'd get the negative 1. And if the 4 is negative, you'd subtract 5 and you'd get the negative 9. So you get these two solutions either way. Pling! Great. So, you're going to practice completing the square. Some of them you could factor. Some of them need to be done completing the square. But we're going to show you the how completing the square gets you the quadratic equation tomorrow, next time I see you. So that's where we're going next with it. So practice it right here with your homework. Cool? Go for it. Be productive.